Welcome to the project demonstration of a framework for the emerging smart infrastructure with IOT Era. So in this project we are going to control the home devices along with the door as well as window blinds. So through these curtains, through these DC motors, and this controlling will be done through the Blink application, and that can be accessed from anywhere in the world. So here these two DC motors representing the curtains and the door, and one is the AC bulb load and one is the 3-pin socket. So these four loads can be accessed through the Blink application, and these four will be controlled through the electromagnetic relays which are connected to the Arduino Uno board, and the communication between the Blink application and our kit is through the ESP8266 Wi-Fi module. So which was interfacing and taking the input from this Blink application, and also it will upload the energy consumed by the so-called devices through this same Blink application. We can access that. So this is a Blink application. Log into the Blink application with the given credentials. The ID and password is written backside of this cardboard. After login, we can see this screen, and so it's offline, nothing but the device is not connected to the internet when it's not getting on. So you can see this kWh readings, as well as 4 devices can be controlled from these switches, below switches. Okay, we have interfaced these 4 relays to the Uno board. Pin number 10, 11, 12, 13 pins, and 0 and 1 is connected to this ESP8266 Wi-Fi module, and pin number 2 is connected to the energy meter reading. As we know that energy meter will provide the LED pulses. First LED will provide the pulses whenever the load was connected to this energy meter. So when the blinking rate increases, means number of blinks increases per second, so that is a parallel indication of the load was connected to the energy meter was high. So here whenever the blinking rate reaches to the 3200 impressions, that will be considered as a 1 kilowatt hour. Means when we have connected 1 kilowatt load to that, then if we run that particular 1 kilowatt load till the 1 hour, then the energy consumed by that load is 1 kilowatt per hour, and that indication was done with the help of this LED indication. It will count up to 3200 same counts. Okay, and let us see the demonstration. So before demonstration, let me show you the power flow. 230 volts AC inputs to this regulated power supply board, and parallelly to this energy meter. So from the energy meter, the output was given to the loads through the electromagnetic relays, and this regular power supply will take 230 volts AC input and provide us the 5 volts DC output, as it has the 4 stages inside that. One is a transformation to step down the 230 volts to 12 volts of AC, and rectification to convert the AC to pulsating DC, filtration to remove the pulses to make that as a pure DC voltage, and after that regulation to make the 12 volts DC as the 5 volts DC output, as the operating voltage of our total components is the 5 volts. Right. So now before demonstration, first of all you can place the load over here or on this 3-pin socket also. Just placing this one, we can see the status of this can be done with the help of this LED. And now before on the kit, as we discussed, log into the Blink application, stay on the screen, and change the hotspot name to project like Smart Project 38. So smart project, all are small letters without any space, without any capital letter, and password should be 123456789. After enabling the hotspots, the prescribed name and password on the hotspot on the data, and keep this AP band should be 2.4 gigahertz only. That's very important. And now on the power supply to the kit, wait till one device is connected in your mobile phone. We can see that one device will be connected, right? One device is connected. Now we can see that on the Blink application the device will be online now, because the offline mark goes away. Right, you can see now we can control the devices. Device 1 on, as a 3-pin socket got switched on. We can see that off, it is off. On, bulb gets switched on. Right, sorry, we need to connect the battery over here for this DC motors. Wait a second. Right, connect to 9 volts battery for this DC motors, and the next, as of now we can see the load kWh reading increasing slightly on this app. You can see that. So we can control the motor, which is representing the door, off. and same thing for the curtain also. If get resets, wait for some time, keep this off again, on. So this will be controlled, off. Right, so it will be based on your mobile phone network. Better to use the 4G mobile phone, don't use the 5G mobile phone. So as the communication from the Blink application to the UNO board to the ESP is very slow when we are using the 5G mobile phone, as it don't support that much speed. Okay, so that's the delay was placed when we are controlling the devices with help of the 5G mobile phone. Right, now I enable the hotspot in a normal 4G phone, so I can access to the device with any other mobile phone. No, can access that in faster manner. We can control. So that we should take care of. We are not supposed to use 5G mobile phone as it providing the low communication data transfer for the ESP8266 Wi-Fi module. Okay, if anything goes malfunction is done, means unnecessarily the device getting on and off continuously, just reset this UNO board. This is the main reset switch. Okay, reset that, let it on, and once it gets switched on, keep the whole device in off state. Now we can on the devices. Right, so we can see the KWH reading also in this energy meter.